let's find, I didn't bring a colored brain. So use one like that, because these are the ones I usually test. I don't use the color, because the color have the names written on. So, when I have a brain, this is how the brain sits in my head, like that. I see I'm not that small, mine's smaller. But you got that little cauliflower thing in the back, so that's your orientation. The brainstem, the light stump, comes out more in the back, bottom back. The front sort of, curved, like it sits above your eyeball. We have a right and a left hemisphere. You always look from the perspective of the person that you look at, the patient, so to speak. It's always the patient's perspective. So it's your right and your left, not the doctor's or somebody examining's right and left. That's not a big deal now, but it becomes a big deal when you try to figure out what somebody wrote down and which viewpoint you use. In between those hemispheres, we got a deep groove or valley that we can go down. Actually, we can go down there until we hit the white part here, which is going to be the connections between the hemispheres. That will be the corpus callosum, that part. But that long, deep valley is the longitudinal fissure that goes down here. So we have a fissure, we have a couple of fissures, but we'll focus on one fissure here. That's a deep groove on there. The ones that are more on top that make the valleys on the wiggles, those are the sulci, or sulcus for a single one. Then, when we look at the lobes of the brain, the front one, guess what? It's the frontal lobe. The one that's on the side, on top side, is known as the parietal lobe. The one that's right behind the ear is known as the temporal lobe, and the one that's behind in the back is known as the occipital lobe. The cerebellum sits right underneath it. If you open the brain up and you look from the side, you see why they call this the cauliflower brain. Looks like a little bit like a cauliflower. Again, all wide and I guess they didn't call it cauliflower. Then we have the precentral and the postcentral gyrus. So you see there's a wiggle that's a little reddish and one's a little bluish. It's on the other brain too, it's just red and blue, a little darker. But the in-between valley groove, that's the central sulcus. And that is the delineation between the frontal and the parietal lobes. There's two parietal lobes and one frontal. So the wiggle, the gyrus, right in front of the central sulcus is known as the precentral gyrus. That happens to also be the primary motor cortex. So that is the place that tells your muscle to contract when you want to walk somewhere and you just do that. But that's the part where the motor commands come from. Then the wiggle behind it is the postcentral gyrus, and that's part of the parietal lobe, and the parietal lobe has to do with sensation, bringing sensation into the body. And so that one is the primary sensory cortex. And that's not seeing or hearing, that's the regular stuff, like feeling, touching, warm, cold, that kind of stuff. Then, we gotta take this brain apart, and I'm gonna hold the part that's put together, and I'll fall it apart. And I'm gonna look at here, I'm gonna see a few things. I'm gonna go down here to the white stuff. So now we're sort of in front of that cauliflower brain, that cerebellum. And we got three main structures that we need to look at. We have the midbrain, and the midbrain is a sliver just right here. I don't tag the midbrain because it's a really awkward place to tag. It's more like an area. But we have a couple of things on that area that we're going to talk about in a moment. Then below that, oh sorry, that's right here. Then below that we have this area where we have a little wiggly structure in the front. And that's a lot of pathways going in and out and up and down. actually the pathways go up and down the brain and in and out to the cerebellum. And that area is known as the pons. So where you have a little wiggly structure here, I visualize I'm turning that brain upside down and I'm walking like over a bridge on my pons. So that's the pons. And then below the wiggle, we pretty much call it medulla oblongata until we hit the spinal cord. And we'll talk about the spinal cord in a minute. We'll talk about that more in a cross section. But we have a couple of structures here that we want to point out. So up here, right above the cerebellum, there's these two little ducts. And those are the ones on top. There's one on each side. The one on top is known as the superior colliculus, and the one on the bottom is known as the inferior colliculus. There's two, so they're colliculi. There's superior colliculi and inferior colliculi. Those are easy to detect, but I also think they're kind of cool because they are the ones who make us look to the periphery when we see something in the periphery or we hear something in the periphery. And so that's kind of a neat structure that is a reflex structure. So that I make you know that. Then the other one I make you know, see, it's not on this brain. I have to get an order for that. The other one I make you know is on this beautiful brain that falls apart. And that's the structure here in the front. If I tag anything in the front, which I don't put this on the test, but I want you to kind of know about a little bit. It's known as the area where the pyramids are. And these are the longitudinal tracts going up and down right in the front that carry the motor input to the muscles. So the pyramidal tracts are what carries the motor input into the muscle from the Postcentral Gyrus to the muscle. So at least that way you have like, oh look, this is the same pathway, starts up here and goes here in the front. So that's kind of why I do that, because the brain is so complicated. There's so many different things. Another structure that is extremely nice to tag on the test is the olive. That's right, there, looks like an olive. And it's called the olive. So it's another reflex integration center. So that's why I put that on there, because it's the one that, if I put it on the test, everybody gets that, right? It looks like a green olive. And believe me, I'll use a brain where it's green. I'm not going to use a brain where it's not colored. Sometimes I put that on depending. And then what we do is we go back up a little bit. Let's use this part of the brain. We go back up above the midbrain, so above that yellow line right there. So it's above basically the colliculi that we have here. And we get into this area. And this area is known as the diencephalon, sort of the middle part of the brain. And we have a couple of structures that I'm interested in knowing there. We have the thalamus, the hypothalamus, and the pituitary gland. The thalamus is this round egg-type shaped structure that actually goes inward and looks like it's roundly like an egg. That's the thalamus. Below that, or in front of that, where we have sort of, you can kind of visualize, look at that, you can visualize this weird thing here. Maybe you can. You can visualize this being a beak of a bird. And that's being the eye of the head and all that sort of stuff. So the front part, where the beak is, right above the pituitary gland, this pink thing here is the pituitary gland. Right above that is the hypothalamus in this area. Because the hypothalamus talks right to the pituitary gland, so it's kind of looked at there right next to each other. And then, oh look at that, I tagged the pituitary gland. Well, there it is, that's the pituitary gland. And the last term there, well there's two more terms that I want from there, but this big thing next to the thalamus, to not be confused with the white one as the thalamus, that's more medial, this is the basal ganglion. Or also sometimes you look in the textbooks nowadays, it's known as the basal nuclei. Because we want to use clusters of cell bodies, we want to name them nuclei and not ganglia. We want to name ganglia clusters of cell bodies in the peripheral nervous system. It's just because in the periphery we have to protect each other, or we have to be more clustered so they don't get crushed. Up here in the brain, it's all protected by a skull, so it's much more free moving around. Okay, then let me put this on here. This is probably a good place to show this. We have the corpus callosum. And the corpus callosum is this yellow structure here that basically connects the right and the left hemisphere with one another. Corpus callosum. That's the one the guys don't have any. That's why they're useless. Except for doing one thing. Refocus. Video game. And now we have a couple more terms there, as you can see on that sheet. We have chambers. This is actually not a non-fitted brain. It just shows the chambers inside. And this is a mold of those chambers that are inside the brain. We have those chambers because we want to circulate cerebrospinal fluid through them. We make it a little more weightless. We also nourish the brain that way. And so this model, in reality, is not stuff. It's liquid. So it's space. So we got two horns here on both, one on each side, and those are known as the lateral ventricles. And then they come together, or that hole goes through and out, and that's actually right in the middle of the thalamus. Right in there, in the center of the brain. That's known as the third ventricle. And then we get this little sliver going down to a wider area on the bottom. And that little sliver is called the cerebral aqueduct. I don't know. Sort of like has around, I don't know. Just got to memorize. And then on the bottom, where it gets wider again, that's where we have the fourth ventricle. And that was not as painful as I thought. So that brings me to the spinal cord.